I'm going to start with number 18, and the first thing that you have to do before you do anything is you have to find the GCF for 75 and 90. Any way that you want. I'm going to use factor trees. Help me out here. Somebody other than Reggie. Give me 2 for 75, please. Use divisibility rules if you get stuck. Give me a number that you know goes into it, and I'll help you out the second half. Oh, that's a good one. You got the hard one, actually, 15. And the other one happens to be 5. Which one's prime, Clemmy? Great. Okay, 2 for 15, a little bit easier. Court. Right. Both of them are prime, right? Okay. Okay, now we're going to do 90. And I need 2 for 90. Amanda. Works for me. Both are composite, so let's break down 9. 2 for 9, somebody. Darn. Got it in stereo, that's good. Both prime. Chase, 2 for 10. Works. Both prime. Okay. Everything's circled nice. Give me one number you see in both trees. Kels. Okay, right, I'm going to cross it out on each tree. I'm going to list it once. What else? Samantha. Cross them out. List it once. Any others? Any others? Any others? Yes or no? No. What's my GCF then? No. Take my 2 factors and multiply it together. Okay, so now here's where it actually starts. Once I know my GCF is 15, that's going outside the parentheses. And I'm going to set it up just like this. Now, ready? 15 times what makes 75? Sometimes if you look back at the factor tree, you'll see right away. Lauren Mods. Right, 15 times 5, that's going here. And then 15 times what makes 90? Log. And that's it, you're done. Okay. Okay, now based on that, and anybody do it the right way for number 19? Nobody? What's my GCF for 36 and 45? If you didn't do it like this and just did GCF, at least just tell me what the GCF is.
9.
Right, it's 9. Ready? 9 times what makes 36? Come on, raise your hand. And 9 times what makes 45? Okay, Chris. That one's done. Okay, this one winds up being 8 and 7 plus 8. And I think, what's the GCF for 48 and 14? Gus? Yeah, it's only 2, right? Can't get anything higher than that. And that's that. And I'm showing it to you again because it does appear on your take-home quiz. I think there's 1 or 2 questions on it. Curls, what page did we leave off in 19? Okay, you're going to go back into lesson 19. And we have to do this, right? Okay, great. I'm going to find the LCM of 3 numbers using methods 1 and method's 3, because you can't use method 2 for 3 numbers. It doesn't work. Can I share you in a little secret? Little secret. When you do skip count, do the largest number first, because the largest number will tell you how far you have to count to, kind of. You'll see. Let's count by 18s. 18. What's next? Good. What's next? Starts getting a little tricky now. What was it? 54. Then keep going. Keep going. I'm going to stop at 90. You'll see that's going to be the one we need. Who wants to count by 15s? Come up. Curls, curls, curls. You're on the air. I'm going to write for you. Don't cover up the microphone. Keep it right there and go.
15, 30, 45, 60, 75, and 90.
Give a round of applause for our guest speaker. Anybody want to come up and do 9? I need another guest speaker. Kelsey, you can come up, but you have to sneeze in the middle. All right, come on up. Clip it to your scarf. Somewhere. Right about there. All right, I'll write for you. You speak.
Wait, is this good?
Yeah, it's good.
Okay. 9, 18, 27, 36, 45, 54, 63, 72,
Walk with me.
81, 90.
Ding, 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 we have a winner. LCM is 90 using method 1. Give her a round of applause for our guest speaker. Thank you. Didn't get a sneeze out of it, but that's okay. Our LCM is 90. Now, when we do method 3, don't forget, we have to get the same LCM as 90, because it's gonna be the same LCM no matter what method you choose. Method 3 is starting out with factor tree. So why don't we do this? I'm going to shut off the microphone for a minute. Just do a factor tree for 9, do a factor tree for 15, and do a factor tree for 18. And then we'll go from there. But don't do GCF. Just do factor trees, and then we'll come back to the recording. All right, so Kaylin is our guest host. She's going to do factor trees for 9, 15, and 18. Go for it, Kate. Knock it out of the park. How many got 3 and 3 for 9? Okay, great. Both prime, so we're circling it. Who remembers? What number are we supposed to be getting for LCM again? Chris. Supposed to get 90, so let's see what happens. All right. How many of you got your factor trees all correct? All right, here's where it gets a little tricky, so pay attention. Ready? I need somebody to tell me a number you see in all 3. Kate, do you see a 3 in all 3? I want you to cross them out and list it only once. Is there another number that you see in all 3? Yes or no? Okay, now here comes the tricky part because this is new. Do you see a number in at least 2 of them? What number would that be? Do you see another 3? I see a 3 here, and I see a 3 here, right? Ready? Cross them out. List it only once. Oh no. Oh no. Kelsey. For those of you that are watching this video blog wondering what is going on, Kelsey Finn just dumped an entire heart's worth of Skittles, all over the floor. And unfortunately, she waited longer than 5 seconds to pick them up, so now she can't eat any of them. And if anybody would like to revisit the spillage of the Skittles on the floor, feel free to log on to the website tonight and enjoy. Kelsey, good? All right. If you see a number that's in at least 2 out of the 3 trees, you're still going to cross them out and list it once. Do you see any other numbers that are common in at least 2 trees? No, right? These are called the common numbers, and everything else that's not crossed out are called the leftovers. What are my leftovers? What do you see that's still circled, not crossed out? A 5 and a 2. Ready? What was the magic number that we had to get? 90, right? 3 times 3. 5 times 2. 9 times 10. And it works. Okay? Like I said, both methods are okay. Whatever works best for you. I'm just telling you that if you choose to use this method here, you got to know your times tables and you got to be able to count correctly, because if for whatever reason, let's say you're counting by 18s, okay, and you go 18, and then you do 36, and then let's just say you do 56 or 52. Now everything is going to be off and you'll never get to that 90, and that's the number that you need. So if you use skip count, you got to count really, really carefully. All right, I'm going to do one example for you, and then I'm going to let you guys work. Find the LCM. I'm going to go to the next page. Find the LCM using any method. I'm going to show you all 3. And then once you have all 3, you decide what method works best for you. Starting with skip count, I'm going to count with the higher number first. Comes out to 48. I'm going to stop there because I know I'm going to need 72. See, while you're counting, I'll know in my head, oh yeah, 9 times 8 is going to get me 72. You may or may not be able to see that right away. What's after that? 45, 54. All of a sudden, I forgot my 9 times tables. 63, 72. What's the lowest number that you see that's common in both? Mike, circle it. That's my LCM. Okay, that's method 1. Here's method 2. I'm just curious, does anybody have any idea what the GCF is without doing a factor tree? If you need to do a factor tree, do it, but sometimes some students can see it. The GCF. 6 won't go into 9, so it won't work, but it's lower than 6. And obviously, it's going to be 9 or less. Okay? It is 3. Ready? Watch method 2. You're going to love this. The GCF is 3, right? We're going to do 12 times 9. Find out what 12 times 9 is. That you may have to do, or sometimes if you know your 12 times tables, you can do that too. John, what do you got? 108. Method 2 says that we can divide the product of the numbers by its GCF. So if you do 108 divided by 3, because we're short on time, I will tell you, you'll get 36. And it works. Finally, here's method number 3. You ready? I'm going to do a factor tree for each number. Okay, there's my trees. Give me a number that you see in both. Caitlin. Yup, cross them out. You only list it once. Anything else you see in both trees? Well, I have a 2 here, hon, but I don't have a 2 here. It's got to be on separate trees. Nothing, right? This is my common. These numbers are my leftovers. So I have a 3, I have a 2, and I have a 2. 3 times 3 is 9. 9 times 2 is 18 times 2 is 18 times 2, 36. If you do it right, you're going to get the same LCM all 3 times. All right, how are we doing on time? Okay, you have 3 minutes. Why don't you guys do number 2 on your own? Pick any method you want now. Just find me the LCM.